If you've ever wondered how AI and ML models are trained or how they learn, those terms get used a lot, then this video is for you. And it turns out there is a foundational algorithm for this called gradient descent. We're going to quickly explain how it works, and then there's a quick coding problem that you can do too. So gradient descent is actually an algorithm that is used to minimize a function. So let's give a quick example of that. Here we have a really simple function, the function y equals x squared, and it's pretty easy to tell that the lowest value on the function is 0, and the x value that results in that is x equals 0. But there are some more complex functions in math, like this one, and don't worry, you won't have to actually do the math by hand for these crazy functions in these ML problems. But there are some functions like this one where it'd be a lot harder to solve for the minimum of the function. And the whole reason this matters for AI and ML, minimizing a function, is because during this training process, what that really means is that we're trying to minimize the error function. We have a function which actually takes in the model's prediction on the current data points, as well as the correct answer on the data points that we want the model to learn to predict. So if we had a data set of a bunch of people and some attributes that affect how tall they'll end up being, like their current height and the height of their parents. And for every person, we have what their eventual final height ended up being. And we're trying to train a model to predict that it can hopefully give us a good prediction when someone new comes along for how tall they'll end up being. So our error function would actually take in the model's prediction for how tall someone would end up being, as well as the actual true answer, the actual label that we have for every person in the data set. And we want to minimize this error function. So let's go over the pseudocode for this algorithm. So here's the pseudocode. For some number of iterations, we will calculate the derivative of whatever function we wanted to minimize. And don't worry, there won't be any crazy calculus by hand, but you want the derivative at the current guess, and then your current guess, you just actually subtract out some number alpha, which is typically something like 0.01 or 0.001, and then alpha times d, which you calculated previously. And then after these iterations are done, you just return the current guess. So a simple example of calculating d is if y is x squared, then the derivative from calculus is 2x. So if my current guess for x, whatever the current guess for the minimum is, if my current guess was 5, then d would actually be 10. So if you actually run this algorithm for enough iterations, your current guess that you end up with will actually be a pretty good approximation for the minimum of the function. So we know the right answer is x equals 0 in this case, and if you started off with some random guess for this function, like x equals 3, and you ran the algorithm for enough iterations, you would get pretty close to 0. But why does this work? Why can you just subtract out alpha times the derivative? Why does that actually work? Well, let's try to build some intuition for that. If we have x equals 3 and we look at the derivative at x equals 3, the derivative is just 2x, so 2 times 3 is 6. And if we remember what a derivative means, it's just the slope of the function at that point. So this white line is called a tangent line, but that term's not super important. And the slope of this line is the derivative at x equals 3. So according to our formula, and I'm just going to use alpha equals 0.1 instead of 0.01 to make the math a little easier. So we have 3 minus 0.1 times 6, and it looks like after one iteration, we ended up with 2.4. So we can see that the value for our current guess actually did decrease, and we did get closer to x equals 0. We can think of this as the slope of this line being positive. This is a line with positive slope, but since we always use the negative slope, we go in the opposite direction, and this actually pushes our answer this way towards the origin, towards the right minimum of this function. Let's say we got a little closer to x equals 2, so we got a little bit closer to the left. Well, the derivative at this point is 4, and again, applying the formula, if we did one more iteration, we would actually get to 1.6. So x is getting smaller, and it's being pushed to the left. It's actually being pushed to x equals 0. So with enough iterations, we should get there. The same logic holds if we started with an x that was negative. This derivative, or the slope of this line, this is negative. So when we actually subtract out the negative of the derivative is negative, we're actually adding to whatever our current guess for x is. So then we actually increase from -2 to -1.6, pushing our guess to the right, getting us closer again to our desired answer of x equals 0. Now that you have some intuition for how gradient descent works, I highly recommend trying the Python coding problem and trying to pass the test cases. If you find it interesting, you can then check out the solution video where we explain even in more detail why gradient descent works.